Around 100,000 commercial planes take off and land every single day. That's almost 2 flights per second. But how often have you heard of a plane's tires blowing out during landing? It's extremely uncommon. Here is why. Plane tires are different from the tires you encounter on a day-to-day basis. They only really resemble automobile tires in shape. When it comes to tire design, special considerations have to be given to the materials used and how they integrate with a plane's safety features. Let's start with materials. You can imagine that regular rubber alone just isn't going to cut it for a plane's tires. That is why plane tires are reinforced with Aramid. It's an incredibly strong synthetic fiber known for its heat-resistant properties and has a melting point of 932 degrees Fahrenheit. For reference, average rubber will catch fire and begin melting at around 500 degrees Fahrenheit. Aramid is also resistant to abrasion, which allows plane tires to be used for up to 500 flights. That's great news for plane technicians, as each tire can take up to an hour to change. But the differences don't end there. Another key differentiation between plane tires and regular tires is in their air pressure. Car tires are commonly filled up to around 30 psi. Plane tires start at 200 psi. The higher pressure makes them extremely firm, almost rock hard. They better be. With commercial planes regularly clocking in at over 100 tons, tires need to be as firm as possible to ensure they don't give under all that weight. Each plane tire is able to withstand a weight load of up to 38 tons. So the heavier the plane, the more tires it needs to ensure a smooth, explosion-free landing. It's not just how plane tires are filled up that makes a difference either. What they're filled up with also matters. Instead of regular compressed air, plane tires are filled with nitrogen. While nitrogen does make up 78% of what we understand as air, the other gases found in air are unsuitable for use in plane tires. Engineers choose to use nitrogen due to its properties as an inert gas, which negates the effects that changes in temperature and pressure would normally cause. In short, it's stable. Aside from this, plane tires also come with a host of fail-safes to prevent tire failure on the tarmac. One fail-safe is actually common among cars, the anti-lock braking system, or ABS. ABS prevents wheels from locking up while braking. These systems automatically engage during emergency situations when the tires are at risk of locking up. This works in conjunction with an anti-skid computer installed on an airplane. Sensors on the wheel communicate with the computer to relieve brake pressure. This prevents the loss of traction when braking, which would quickly lead to the explosion of the tires. Another fail-safe is unique to plane tires, the fusible plug. These plugs melt once they reach a certain temperature threshold, causing the plane's tires to deflate safely rather than blow out. These especially come in handy during instances where maximum braking is applied. Common scenarios where this is used include emergency landings or aborted takeoffs. The safety measures seen in the design of a plane's tires are but one piece of the puzzle. Engineers have honed the systems behind planes over the last century to the point where, according to statistics, boarding a plane is safer than swimming.
Goodbye, Tom.
Driving. Or even taking your bike out for a ride. So the next time you find yourself on a plane, you can rest assured that nothing will go wrong.